All right, as applications of the variation of parameter, I'm giving us two examples here. I want us to solve this by following the 4 steps I mentioned in the previous video, okay? So the first example, we are given this equation is this non-homogeneous equation subject to this condition, y of 0 equal 1 and y prime of 0 is equal 0. And the second example is also simple. So let's start with this. The first step says that you have to solve the homogeneous equation. First step, solving the homogeneous equation here means the second derivative minus y is equal 0. So the auxiliary polynomial here is lambda squared minus 1 equals 0. So this means lambda is equal plus minus 1. Okay? This is what we obtain. Then y1 is equal e to the power x, and y2 will be e to the power minus x. So this is the homogeneous solution. We have to check if these are linearly independent. So we use the Vronsky. If you remember the Vronsky I explained is y1 e to the power x, y prime 1 e to the power x, y2 e to the power minus x, and this is minus e to the power minus x. If we cross multiply these, we have minus 2. This is different of 0. So the system y1, y2 is linearly independent, okay? So y1, y2 is linearly, this system is linearly independent. Therefore, the homogeneous solution here is just all right. Now that we have this, let's move to the second step. For the second step, we want to solve for yp equal u1 of x, y1 plus u2, y2 of x. Okay, this is the particular solution. And you remember that the total solution or the general solution is just the sum of the homogeneous plus the particular solution, okay? So remember the second step. In the second step, I derived this matrix y1, y1 prime, y2, y2 prime. All this multiply u1 prime and u2 prime is equal 0 f over a. F here is just e to the power x. F over a 2. So this implies that y1 is e to the power x. The derivative will be e to the power x. This is e to the power minus x minus e to the power minus x. Okay? This multiply u prime 1, u prime 2 is equal 0 e to the power x. So at this stage, we can use different approaches. So if we call this matrix M, then for the first approach, we can just find the inverse of this matrix, okay? It's a 2 by 2. Remember this, for a 2 by 2 matrix, A, B, C, D, then the inverse So remember that if M is a 2 by 2 matrix given by this A, B, C, D, then the inverse of this matrix is given by 1 over, this is 1. 1 over the determinant of M times this matrix, okay? All right, so we can either use this or we can use the Cramer's rule. The Cramer's rule says this. Find U prime 1 by using the determinant of M1 divided by determinant of M. So we already have the determinant here. This is e to the power x, e to the power x, e to the power minus x, and here is e to the power minus x. And for this, we start with this part, okay? This is 0 times e to the power x, and we continue with this. This is e to the power minus x minus e to the power minus x. So solving this, we have minus 1 over minus 2. So this is just half. So if we know that u prime 1 is half, Then u1 will be just the integral of this. This is half of x plus c1. So for u prime 2, we use the determinant of m2 divided by determinant of m. So this is, again, we start here. For m2, we start with e to the power x, 0 and e to the power x. We divide by this same denominator, e to the power x, e to the power x, e to the power minus x, minus e to the power minus x. So by solving this, we have the numerator is e to the power 2x and the denominator is minus 2. So this is minus half of e to the power 2x. Okay? So with this, we can then integrate u2 and obtain u2 is minus 1 over 4 times e to the power 2x plus c2. All right, at this stage we have u1, u2, and we can obtain the particular solution, okay? And we can then sum the particular solution to the homogeneous solution to obtain the total solution. So y, the total solution is the sum of this, a times e to the power x plus b times e to the power minus x plus u1 times, this is u1 is half of x plus c1, all this multiplies e to the power x plus the last part is minus 1 over 4 times e to the power 2x plus c2 e to the power minus x. Okay, so if you multiply this through, we obtain the following: a times e to the power x plus b times e to the power minus x. Multiply, this is half x times e to the power x and c1 times e to the power x. For the second part, we have minus 1 over 4 times e to the power x plus c2 times e to the power minus x. So this term and this term and these other terms are all similar. So we can take, and they are all multiplied by a constant, right? So the general solution here, y is, if we look at this term, and these other terms are similar. So let's call it alpha times e to the power x plus, for this one, and this, if you write them together, and b plus c2, let's call it beta times e to the power minus x, we remain with 1 over 2x times e to the power x. So this is the solution. Okay? All right. With this, we want to find, the question says that this equation is subject to y of 0 equal 1. Y of 0, if we say y of 0 is equal 1, it means that y of 0, this is alpha plus beta, is equal 1. For the second one, we say y prime of 0 is equal 0. So if you derive this, the first term derivative is still the same. So if you take y prime of 0 equals 0, this is alpha minus beta plus half is equal 0. So we can solve this for alpha and beta, and we have alpha is 1 over 4 and beta will be 3 over 4. So with alpha and beta, we can then write the totals, the solution in this form: 1 over 4 times e to the power x plus 3 over 4 times e to the power minus x plus 1 over 2x times e to the power x. So this is my solution. Okay. All right. This is all for this example. So for this other example, I want you to solve this. All right, take 5 minutes to solve this question. Just pause the video for 5 minutes and solve this by using exactly this method. And let's come back and compare your solution to what I propose. All right, welcome back. I hope you get the solution. My solution is the following: alpha cos x plus beta sine x minus cos x times logarithm sec x so this is my solution. Please check and compare your solution to this. If there is a mistake, go through again, follow the step and make sure that you obtain this solution. Okay, so this is all for this video. I'll choose some questions from the tutorial and solve in the following video. Hopefully you'll be able to follow me there. Cool, I look forward to seeing you. Bye.